Alright, today we're talking about unit multipliers, dealing with multiple unit multipliers. Now, unit multipliers is seemingly a new idea, but of course it's really not that different because you've been solving these types of problems for quite a while now. But we want to make sure we mathematically understand all the different steps so that we correctly get the labels that go along and don't miss any steps with our conversions. So let's get into this and try this out. It says to use two unit multipliers to convert 5 hours to seconds. And mentally, I bet you probably have gone bing, bing, boom, and you've already started to solve this problem. But how do we visualize what's going on here? We're going to start with what's given to us. We have 5 hours, and we can go ahead and place that over 1 because a unit multiplier is going to be a fractional type idea. So we want to have a fraction to begin with. At the same time, we want to know where we want to end also with our labels. And of course, we want to end with the idea of seconds, and there isn't a rate or anything like that, so we can just place that over 1 also. So from here we want to work backwards to understand how do hours become seconds. And of course hours become seconds first of all by converting hours to minutes. And so by converting hours to minutes, we're going to say, okay, let's make this minutes to begin with. As we deal with minutes, we know that there are 60 minutes in 1 hour. And suddenly we see a relationship. This relationship that we see here is that our symbols of hours are now going to cancel each other out. By canceling each other out now, we now have 5 times 60 minutes. And 5 times 60 minutes is going to get us closer to our answer. However, we're not quite there yet because we want to get to seconds. So now we have a label of minutes. The hours have been eliminated. So now we want to figure out, well, how many seconds are there per minute? And so I know that in 1 minute there are also 60 seconds. And so as I look at this idea, then I would say, okay, suddenly my minutes here get crossed out with my minutes here, and I'm left with not a whole lot going on. I have a lot of 1s on the bottom. I got a 1 times a 1 times a 1, and of course that equals 1. I have a seconds on the top just like I wanted right here, and that's what I'm going to get in the end. So now I just got to take my numbers, my 5, my 60, and my 60, and multiply those numbers together. Now of course I know that 5 times 60, if I put those two together, gives me an answer of 300. And I know 300 times 60 is going to give me an answer of 180. And then throw a couple zeros in there, 3 of them to be precise, and suddenly I'm left with exactly what I need to solve this. 18,000 seconds is how many seconds are in 5 hours. Alright, so we took that step by step to be able to solve this problem. A logical process. Let's see if we can do it again. It says Diego wants to carpet a 16-foot by 9-foot room that has an area of 144 square feet. Carpet is sold by the square yard. How many square yards of carpet does Diego need? Now the key part here is they've given us an area of 144 square feet. Now this square feet could also be written in another way. We could erase the square and the feet, and we could talk about feet to the second power. Now anything to the second power would be feet times feet. So what does that mean? In the end, we want to get in the final answer of yards squared, because we're dealing with, well, it says square yards, but it's also just due to the fact that we're dealing with area. Because of this, we need to do some conversions. And so we want to come away with this idea, and it's not a rate, so it's going to be over 1. So first of all, we need to start to think about how do we get yards squared. Yards squared, of course, is yards times yards. And so we need to have somewhere in our problem now, we're going to need to have yards times yards. And suddenly we are actually figuring out exactly what it is that our operation is going to be. Because our feet times feet must also be eliminated. So there's 1 foot that can be eliminated. There's another foot that can be eliminated. And suddenly I can say, okay, well, what is this unit multiplier, yards over feet? And you would say, well, 1 yard equals 3 feet. And 1 yard equals 3 feet. And from here, we can start crossing things out. This foot is going to get rid of 1 of the feet, and this foot is going to get rid of all of the feet. And of course, since we have yards and yards, we're going to end up with our yards squared. So, numerically, we're left with just a bunch of numbers. 144 times 1 times 1, which gives me an answer of 144. And underneath that, on the bottom, I get 3 times 3, so 144 divided by 9. Now, 144 over 9, I would like to put it like this and make my conversion a bit simpler. 9 goes into 14, 1 times 1 times 4. Right? 54, let me scroll down the screen, and 9 goes into 54 16 times. Sorry, 6 times, so we can see all that work like that. And so I can take this 16 right here. I'm going to change color just for emphasis. And I can throw it way over here where I was looking for my final answer. And in the end, I've determined that 16 yards squared is the amount of carpet that I would need to purchase, or Diego would need to purchase. If my name was Diego, then, well, I guess it's me. We have these different steps that we see taking place. Let's do one more together before we, well, let me just double check and make sure I got one more prepared. You are in luck. I have more than one prepared. I got 2 more samples for you. Let's get cracking on these. It says a masonry contractor needs to pour a concrete foundation for a block wall. The foundation is 1 foot deep, 1.4 wide, and 100 feet long. I bet you this is supposed to say feet. Whoever this guy typing this stuff up needs to do something called proof reading. Anyway, so we got 1 foot would make a lot more sense, not 1 feet. Now we can't read any of it. 1 foot wide and 100 feet long. A cement truck will deliver the concrete. How many cubic yards of concrete should the contractor order? Well, to determine this, we need to first of all figure out the volume in feet. So we're going to take volume, and volume, of course, is, we're going to keep it simple and say length times width times height. And we got 1 times 100. And that's easy math. 1 times 1 is 1, and 1 times anything is 100. So we're going to come away with 100, but this was feet times feet times feet. And so I have 100 feet cubed. So that's where we're going to start our problem this time, 100 feet cubed. But of course, in the end, we want to come away once again with yards cubed. With that in mind, we're going to set this up. And once again, we want to eliminate feet, which hopefully we can start this. Because, right, we're going to need yards times yards again to come away with our answer. So that's 1 yard over 3 feet, 1 yard over 3 feet, and 1 yard over 3 feet. Now, this foot is going to get rid of 1 of these, so now we have feet squared. This foot now gets rid of squared feet, and this foot gets rid of our last foot. So our foot label is now gone. Our yards give us our yards cubed. And so now we're going to just deal with our numbers. 100 times 1 times 1 times 1, right? 100 gives us an answer of 100. And 3 times 3 times 3 gives us an answer of 23. 7. So our fractional parts is 100 over 27, which then we, of course, would rewrite that and try and simplify this just like this. And very quickly, we may find out that we're not really going to come away with a complete answer here as we're dealing with this, but we can solve this anyway. We're going to throw a 3 up there real quick, and 3 is going to give us an answer of, thought I had it, didn't have it, got it back, 81, I believe. Does that look good to you? Double check my math, that'd be great. Subtract that, and that gives me an answer of 19 left over. So 19/27 left over. All right, as I look at this 19/27, that number is accurate, but it's really a hard number to try and figure out if that makes any sense at all. So I'm gonna keep going with this, put it into some decimals and see what we can get. So I'm gonna throw a decimal up there, throw a 0 here, pull it down. We got 190 now. 27 goes in 197 times. And so now we got a 9, a 4. Ooh, that was so close. So close. And we're going to come away with kind of this repeating decimal pattern. And so what I'm going to do is I'm going to kind of chop this off like this and just round to my nearest cubic yard of 3.7, which rounding can be okay. We just got to get a really good measurement. So it's about 3.7 yards, cubic yards. So we come away with that response. And that's our sample. All right, we're going to take it up a notch and do one more. Says, as Tina approached the traffic light, she slowed to 36 kilometers per hour. Convert 36 kilometers per hour to meters per minute. Right. Okay, so she is saying she's going 36 kilometers in 1 hour. Suddenly we have 2 labels that we need to get rid of because we want an answer with meters per minute. So we want to start to convert things to work with that. So let's start with the top. How are we going to get rid of kilometers and turn it into meters? We know that 1,000 meters equals 1 kilometer. And by doing that, my kilometers and kilometers is going to go away. And so I have that part figured out. But the other thing I need to go away is this hours. And so hours, and I want to end up with minutes on the bottom, so I'm going to put minutes on the bottom. And that means I'm going to need hours on the top, and 1 hour, of course, equals 60 minutes. And so we have a very different kind of unit converter, nothing we've really seen before, but it still works because suddenly our hour is going to eliminate this hour. And suddenly we're left with a problem, right? Our meters are going to make their way here. Our minutes are going to make their way here. So we just got to deal with some numbers. And our numbers end up being 36,000 divided by this 60 right here. And so we can do that. And then, of course, we want to solve this problem right quickly. And so we're going to come away with an answer of, looks like 600 meters. So it'd be 600 meters per minute in 1 minute. That is I feel like that is fast. Really fast. Too fast? Am I going too fast? Nope, not too fast. Alright, this video has been long enough. It is time for you to try one and make sure you can do this on your own. Come ready with your questions if you have any. That's it for Unit 88. Lesson 88? Unit multipliers. That's where that word came from. 88.